Hey guys, welcome back to Algebra 2. Today we are talking about using linear models. And so we're going to write linear equations that model real world data and then make predictions from linear models. So these are scatter plots. So there are two sets of data plotted as ordered pair. And so it shows a correlation. So there's like a relationship between these data points. Okay, and there's either a strong negative correlation, and so scatter plot, it's like the line of best fit. Like if we were to draw a line through the best fit of these dots, that's not a very good line of best fit, but if we were to draw a line of best fit, it's a negative slope. So it has a negative correlation. As x's increase, our y's decrease. Okay, for a weak negative correlation, it does still have a negative correlation if we did our line of best fit. Okay, but it's just kind of weaker. These are tight and these are kind of more spread out, but it's still, as x increases, our y values decrease. And then here, if these scatter plots are just all over the place, there is no correlation between x and y, so it's just no correlation. Here we have as x's increase, our y's increase. So this would be a weak positive. They're kind of spread out more. And then here is a strong positive correlation. And it's very easy to see as x's increase, our y's also increase. So let's talk about how we can relate this to a real world application. So this table lists average monthly temperatures and electricity costs for a Texas home in 2008. So the table displays the values rounded to the nearest whole number, and so we're going to make a scatter plot and then describe the correlation. So if you look here, so in January the average temp is 61 degrees in Texas. That sounds amazing. So then the electricity bill is about 150 per that month. So February is 58, 139, March 67, 172. Okay, here let's go down to June where it's 83, and here it's 234. So if you notice, as our temperature goes up, the electricity bills also goes up. Same with July, 84, it's 255. And then September, it's starting to cool down. It's going a little lower, 210. November, it's cooler, so it's 132. December, it's 110. Okay, so the correlation here is, and if we plotted these, okay, we don't care about the, these are like your x, this is your y, x, y. So when the average temp is 61, then we have an average bill of 150, which is right there. Okay, so all of these points here is a scatter plot. And if you notice, it has a positive correlation. As our temperatures, as the average temp of Texas, as it increases, the higher the electricity bill is, right? And so this is a positive correlation. And so, again, as temperatures increase, our electricity bills decrease. And so they kind of relate to each other. Like the electricity bill depends on what your temperature is. And so this is a positive correlation there. So here let's talk about we're gonna make an equation. So it says, the table shows the median home prices in California. What is an equation for a trend line that models this relationship between the time and the home prices? Okay, so we need to find an equation for the line, which is y equals mx plus b. Okay, m being our slope and b being our starting point, our y-intercept, which in this case is going to be our starting point. What is the starting, median value, which, again, is going to be right here. Okay, so our slope, remember, is y2 minus y1 over x2 minus x1. And so what we're going to do is we're going to take 2 points and plug it in. With this, because it is a scatter plot, because it is just an average, it's not going to be the exact same. There's no, it's a line of best fit. It's not going to be perfect. Answers are going to vary here. So whatever 2 points you pick, it's not always going to be perfect, okay? Wait 1 second. Don't go anywhere. I'm grabbing a calculator. Okay, so whenever we're doing this, I'm just going to pick 2 years. Technically, it doesn't really matter because it's not going to be like the rate of change between these 2 years isn't going to be the same as these 2 years. If it was an actual linear model, it would be the same. In this case, since it is just a prediction, there's no perfect set slope. So your answers are going to vary depending on what years you choose. So on this one, I'm just going to pick the first one and the last one. It doesn't matter, and I don't know why I'm doing that. I'm just being extra. So, or we can just do these two right here. Let's do that. That sounds better. Okay, so our year is our X value, median price is our Y value. So we're going to take the difference. So 57900 minus 36700 over 1950 minus 1940, which is 10 years, right? If they increase by 10 years. So I'm going to take 57900 minus 36700, which is 21200 divided by 10. Okay, those zeros cancel. So we have 2120. Okay, well, what does that number even mean? So basically what that means that each year, so from like 1940 to 1941, the price is going to increase by about $2,120. So then from 41 to 42, so each year it's increasing by about this much. So then after 10 years, we have that jump, roughly. Okay, so that is our M. So we have Y equals $2,120 times X, depending on the year, after 1940, because that's what our starting point is. And then again, plus whatever our starting value for where we started, which is we're looking for what is the trend for each year. And our starting year for this is 1940. Okay, this is technically year 0. And these are years after 1940. So this would be like 10, this would be 20. These are 20 years after 1940. So our starting year, our starting value that we're starting by is the 36,700. So it kind of, and also if like we graphed this and if we went back further, you know, that this kind of, these numbers are not exact just because if we did it from these 2 points, we would get two total different numbers for our slope. But our y-intercept would be the same because that's what we start with. Okay, so here, that is it for this lesson. So there's only 3 questions. I'm talking about relationships between scenarios. And so that's it. So that's lesson 2.5. Let me know if you have any questions.